All right, so let's start off. What does your math voice say? What move would we have to do to finish this up? What derivative rule would we look at? Quotient rule. So I'm going to set up my u's and my v's. So u would be equal to 10x to the negative 1 minus 7x squared. Now bear with me on this one. There's a point to this. This is going to be a little bit overwhelming, but you're going to see that there's a point to this. Okay, so my u is my numerator. My v is my denominator. 6x to the negative 4. Now that's still 6x to the negative 4 because I'm doing the quotient rule. If I wanted to try to bump that up to do a product rule, I could, but that's not the point of what I'm trying to do here. You're going to see at the end how this all comes together. Anyway, all right, so now I want to derive u. That means that I would do, these are all sum difference rules with the power rule, so that would be negative 10x to the negative 2. That'd be negative 14x. That'd be 36x to the third. And then I'm going to go fairly quick here because this is old news and you guys are just kind of following along thinking about what's happening. That'd be negative 24x to the negative 5. All right, now we're going to apply the quotient rule, which is u prime v subtract uv prime. So now at this part you're going to want to write small because there's going to be a lot of stuff that we're going to have to put together. It's actually not too bad to put together, but it's going to look nasty. All right, so it would be u prime times v. So that would be negative 10x to the negative 2 minus 14 plus 36x to the third times 6x to the negative 4. Subtract 10x to the negative 1 minus 7x squared plus 9x to the fourth times negative 24x to the negative fifth all over 6x to the negative 4 squared. All right, what does your math voice say to do with all these parentheses? Distribute. And so I'm going to distribute. Again, I know I'm not going to do a lot of explaining here. I'm just going to kind of distribute it as we go. So I'm going to distribute this 6x to the fourth. 6x to the negative fourth. I'm going to distribute that into all three of these pieces. So that would be negative 60, x to the negative 6th, subtract 84, x to the negative 3, plus 216, x to the negative 1. Then I'm going to take this negative, I'm going to distribute this second group, but before I do that, I'm going to take this negative, I'm going to attach it to this. That's going to make it into a positive, and then I'm going to distribute that chunk into these three. So that would become positive 240 x to the negative 6th, subtract 168 x to the negative 3, plus 216 x to the negative 1, all over. And then I'm going to square this, which means I square both chunks because there's no adds or subtract. So 6 squared would be 36. X to the negative 4 squared would be x to the negative 8th. Math voice? Combine like terms. And so luckily, surprisingly, we have a lot of like terms here. So we've got a x to the negative 6 and another x to the negative 6, negative 3, negative 1, negative 1. So we would get, if I put these together, 240 take away 60 is 180, x to the negative 6th. Negative 84 minus 168 is negative 252, x to the negative 3. And then 216 plus 216 is 432, x to the negative 1, all over 36x to the negative 8th. All right, now we can reduce this. Each one of these are all divisible by 36. I already checked this on my calculator earlier. So 180 divided by 36 was 5. Now what's going to happen to my exponents? Do you guys remember what happens? If this were to flip up, it would become x to the positive 8. And then when I give it to the negative 6, it would become x squared. And then same thing here. Negative 252 divided by 36 is subtract 7. And then when I flip this part up, that would become x to the 5th. And then 432 divided by 36 is 12. And when I flip that up, that would become x to the 7th. So nicely, surprisingly, our derivative after all that mess simplified to turn out to be something very nice. Now, if you remember from the partner quiz on Friday, and some of the things that we've been talking about, especially with the trig stuff, is that you can do it however the problem sets up. There are lots of different ways to do each one of these derivatives. But the other option is to look at this. What did we have to do at the end? We had to clean it up anyway, right? We had to reduce things. We had to flip all the negative exponents up. What we can do to avoid that is do a rewrite. What I mean by that is I can take this and I can start to simplify it right off the bat. What's 10 over 6? If I said reduce that, what would you get? 5/3. Now, the rewrite is still f of x. This is not the derivative. This is a rewrite. 10 over 6 would be 5 over 3. X to the, I can flip this up and it would be cubed. Because it was -1, those -4s would flip up. Minus 7 over 6 would be 7 over 6, x to the, that would flip up and be x to the 6th. Plus 9 over 6 would reduce and be 3 over 2. Those x's would flip up and be x to the 8th. By doing this rewrite, we've taken this problem that was a quotient rule problem with a bunch of negative exponents and positive exponents and reduced it into what style of problem? This is now just power rule with sum and difference, which means I can derive this in one step. F prime of x equals 3 times 5/3, the 3 would cancel and I'd get 5x squared. If I do the 6 times 7 over 6, the 6's cancel, I get minus 7x to the 5th. And if I do the 8 times the 3 and divide by the 8 by the 2, that'd be 4. 4 times 3 would be 12. Take away 1 would be dun dun dun. What do you notice? It's the same thing. All right, so what's the point? What's the point? We have a saying in calculus. Simplify early and often. Which means, as you're going through a problem, if you can simplify at the beginning, it's probably going to make your life a lot better. Now, it works if you don't. Here's the proof. We just did this exact same derivative. In both situations, we got the exact same answer. One took a bunch of distributing and about 6 lines of work. The other one took 2 lines of work. All right, so that's the game we're playing today. So flip it over. If you were going to do this problem, you would have to do overall a quotient rule, because it's overall a division problem. And then as you were doing the quotient rule, you guys might remember a couple of, was it last week or the week before, that we did a problem like this. This would be a quotient rule involving a product rule. So we're going to try to avoid that. So let's see if you and your friend can do the first level of rewrite. This is a rewrite. This is still what y is. Think about what you could do to make this problem a little bit better. Okay, hopefully your math voice said distribute the numerator. So that's what my math voice said to do, and that's what I'm going to do. I'm going to avoid the product rule here. I'm still stuck with the quotient rule for the time being. We're going to see if we can fix that. But right now I'm going to distribute. So x squared times x cubed would be x to the 5th or 6th? 5th. You add exponents when you multiply. You multiply exponents when you do to the power. So that'd be x to the 5th. Now I'm going to do them a little bit tricky because I like mine to be in order. So this would be x to the 5th, and then I'm going to go do that one next would be x to the 3rd. Then I'm going to do that one next would be 2x squared. And then I'm going to do 1 times 2 at the end to be 2. If you flip-flop these, that's fine. That's fine. That's fine. Over x to the 5th. Now, life is better. Who did we just get rid of? We don't have a product rule anymore, but we still have a quotient rule. But if you have something over just one term, what we can do is we can break that up. Essentially what you're doing is you're dividing each one of these chunks by the number on the bottom. So let's see, what would your rewrite look like? I'm just going to keep rewriting on the end of my current rewrite. I'll give you a hint. The first one should be 1 plus. You and your friend try to do the next part. I got 1 because it was x to the 5th over x to the 5th. 1 over 1 is 1. X to the 5th over x to the 5th cancels and leaves me with 8. Be careful, it doesn't cancel and make a 0. All right, just to see how you're doing so far. X to the 3rd over x to the 5th would make x to the negative 2. I move on to my next chunk. That would be 2. X to the 2 over x to the 5 would be x to the negative 3. And then the last one would be 2. And then this one doesn't have an x, so when I bring it up, this would be completely x to the negative 5. Now what's so nice about this, and again, is the whole point of what we're doing, is that now I can take this and I can just derive it. And using my derivative is only going to be using the power rule, sum and difference rules. So this would be y prime, because I'm now doing the derivative. The derivative of 1 is 0. Negative 2x to the negative 3. Negative 6x to the negative 4. Negative 10x to the negative 6. Where did I mess up? Yes. As long as it's the same stuff, it doesn't matter what order it's in. Okay, now let's try to apply our warm-up at the beginning today. Let's see if you can factor out least powers. I'll give you and your friend 15 seconds to discuss what do you think the GCF will be. What is the thing that you're going to factor out? I'll give you 15 seconds. Go. The only way to learn this is to jump in and do it. I don't know. There's no shortcuts here. This stuff is tough, but it's doable. If you dig in and try along the way, you'll get there. If you don't, you'll never make it. Okay, let's have a chat. So what I would do if I'm going to factor out least powers is I'm going to look at everything that I can take out starting with the coefficients, and then I'm going to move to the exponents. So I'm going to start with the coefficients, negative 2, negative 6, negative 10. What would you say they all have in common? A negative and a 2. So I'm going to GCF out a negative and a 2. When you do a factor out least powers, you try to take out the worst stuff that you can. Then, this is called factor out least powers for a reason, is you always want to take out the least power. That would be x to the negative 6, because that's the least of those exponents. Even though it's the biggest number, it's because it's negative. It's the least. All right, so what would that leave behind? This would become x to the 3rd plus, why did I write 6? X to the 3rd plus 3x squared plus 5. Turn and talk with a friend. What the heck just happened? Make it make sense. And again, the reason we do this is so now we've taken out the nastiness, and it's really nice to kind of organize nice stuff together and gross stuff together. Notice that the x was the only piece that flipped, not the negative 2. The negative 2 is not a negative exponent. The negative 2 is a coefficient, so that's going to stay in the numerator. The x to the negative 6 is going to take down to the bottom. And then what would be nice about this is now we can look at this and we can, again, like I said earlier, when you try to figure out the the horizontal tangent line and the vertical tangent lines, they're really easy to tell at this point. Okay, so we did one where we had to distribute first and then clean up. Now we're going to do one where we have a root. So again, I'm going to start off with a rewrite. Now look. If you want to, you can still do your U's and V's. They will work. But then your cleanup at the end to match, this would likely be a multiple choice question in AP Calc because it's so straightforward. The cleanup at the end would be a pain in the butt. So let's do a rewrite now to try to avoid it. All right, so I've got 7x plus 3x squared. I'm leaving that the same because I'm okay with that. I don't mind that stuff. That's not anything that's nasty. But we look at the denominator, and I have 5 root x, which I want to rewrite as 5x to the, all right, question. Should this be x to the 1/2 or x to the negative 1/2? 1/2, because we're leaving it down there. If you want to turn it into an x to the negative 1/2, you can, but then you got to write it up here with a parenthesis and then distribute it. Okay, now look at what we did up here and see if you and your friend can figure out what we're going to do here. So I did x to the 3rd over x to the 5th became x to the negative 2. Do that same concept down here. Let's see if you can do it on your own first. What do you think it'll look like? And if you can't do it, try it. But if you can't, we'll fix it together in about 30 seconds. Okay, start with the coefficients. That's the easy part. So the coefficient on the first chunk is a 7, and then the bottom is a 5. So my first fraction is going to, or my first term is going to be 7/5, and then I'm going to subtract these exponents. This is x to the first. So x to the first take away 1/2. 1 take away 1/2 would be 1/2. Plus, my coefficient on the top is 3, and then on the bottom is 5, so this would become 3/5. My exponent is 2. Now, if you want to take 2, take away 1/2. If you want to be lazy, you could probably do this in your head, but if you want to be lazy, I'm going to change 2 into 4/2 so that they have a common denominator. And then now I can subtract 1/2, and I would get 3/2. The beauty of this is now we don't have to do the quotient rule anymore. We can do our favorite rule, well, my favorite rule, which is the power rule. All right, you and your friend, see if you can do the power rule. Then we'll practice to clean up least power, or factor out least powers afterward. All right, let's see how you did. So I'm going to multiply, subtract 1. So 1/2 times 7/5. In my brain, I set them next to each other and see if anything cancels, and nothing cancels. So that would be 7/10, x to the, and I would subtract 1 from 1/2. That would be negative 1/2. Plus, again, I would set 3/2 next to 3/5. Nothing cancels, so that would be 9/10. X to the 3/2 take away 1. If you can't do that in your head, go into your margin. 3/2 take away 1, change 1 into 2/2. 3/2 take away 2/2 would be 1/2. What do you think? All right, let's practice factor out least powers again. Get the nastiness out front. All right, let's see how you did. So start with your coefficients. 7/10, 9/10. The over 10 is the piece that I like the least, so I'm going to take that out. Then I look at the numerators. Do we have anything in common, 7 and 9? No, so the best I can do is take out the 1. Then I look at my x's and I take out the least exponent, negative 1/2. And then now from here, I build back what I had. So 1, let's say, so that would need a 7 plus, this one would need a 9. And then remember, what you're doing here is you are subtracting. So this is going to be 1/2 subtract negative 1/2. So 1/2 subtract a negative really means add. 1/2 plus 1/2 would be 1. And now I can nicely reorganize this into, I like to put the linear term first. So this would be 9x plus 7 over, and then on the bottom, the 1 gets absorbed into the 9 and the 7. 10 times the square root of x. What do you think? All right, you're up. Last one's all yours. So this split up first. You might have to do some margin work. I would definitely do a rewrite here, because if I didn't, I'd have to do quotient rule with fractional exponents, barf. Okay, if you need a hint, the first one I got was 1/2 x to the 3/2. Who wants me to explain how I got there? Anybody? Nobody? It was 6/4, and I reduced the 6/4. 7/14 reduces. This would be no calculator, yo. Okay, I'm going to try the next one. First of all, it's going to be a subtract. I'm just going to deal with 44 and 14. 44 and 14 are both definitely divisible by 2. That would turn 14 into 7. And 44 into 22, yeah, 7 and 22 don't have anything in common. So this would be 22 over 7, x to the, all right, if you can't think about it, write in the margin. Just go to the margin and write it out. So this would be negative 7/4, take away 3/4, which would be negative 10/4. But negative 10/4 would not be okay, because we can divide both of that by 2, so I would get x to the negative 5/2. What do you think? I'll give you a little bit longer on the last one. Now the last one I definitely had to go into the margin on, because it was that stupid 28. The other one had common denominators. Why didn't they make that 32 out of 28 and then reduce it for us? But they didn't, and so we kind of hate their guts. I know. Shaking your fists at them like an old man with kids on his lawn. Why I oughta? Did you say I did that pretty good?
He's gonna do that.
Did you say that because I'm an old man? What the heck? No, I'm JKing. I'm JKing. I'm JKing. Wait, what? You missed it, man, and it was a blast. Top Gun, I feel the need for speed. That's a negative, Ghost Rider. The pattern is full. It's actually pretty cool. It's just like us in the theater. It was our own. Nobody else was allowed in there. It was just me and my friends and family. Okay. I'll do the coefficient real quick because 14 over 14 is 1. What's up? 1. See you later. And then now I've got to do the exponent. So that would be 33 over 28 subtract 3 over 4. Now I'm lazy when it comes to this work. I don't like to rewrite everything. I just kind of do it above it or around it. So 3 over 4 can be turned into common denominator, would need a 7. So I'm going to be a little bit lazy. I'm going to times the top and the bottom by 7. So that would be 21 over 28. 33 minus, I wouldn't be able to do this part in my head. I would have to write this out. 33 take away 21 would be 12. And then I've got my common denominator 28. Both of those are divisible by 4. So that would leave me with a 3 over 7. So that would become my exponent, 3/7. Okay, how much calculus have we done so far? None. 0 calculus has been done. So the calculus part even though the idea of calculus is by far more difficult, like the stuff that we do with calculus is more difficult than algebra. It's the algebra that usually trips people up. So now we can just do the derivative, and don't try to factor out least powers on this one because they don't have a common denominator. That trick only works if all the denominators are the same. If they're different denominators, you're going to run into a mess that nothing is going to actually become nicer. So I'm going to now just apply the power rule with the sum and difference rule. So that would be 3/4. X to the, take away 1, would be 1/2. Okay, do this in your head. A negative times a negative is a positive. Then set the 5 and the 2 next to the 22 and the 7 and see if anything cancels. Does anything cancel? The 2 and the 22 is going to cancel. It's going to leave me with an 11 on the top, the 5 on the top, and a 7 on the bottom. Nothing else reduces at that point. So 11 times 5 would be 55 over 7. And then I'm going to subtract 2 halves. So that would be -7 halves. Plus, and then the last one is the easiest of them, even though it took the most work to get there, would be 3/7 x to the, and then I'm subtracting 1, which would be 7/7. So 3 take away 7 is -4/7. We would not try to clean this up. This does not clean up nicely. All right, folks, that's it for today. The rest of the time is yours to work on homework.